today I'm going to show you guys how to make a pen platform on Scratch and just demoing this one that I made pretty recently. This is not done yet, but I did share it just in case anyone wants to try it. So this is it. This is what you'll be able to make after this demo. So as you can see, it's pretty nice platformer. You got like a nice background, movement acceleration, effects, directions, pretty much everything. So this is actually all done with a pen. I'm going to show you how we did it. So just organized everything here. So the pen, I used one sprite in this, and that would be the character, just because if you make a pen platformer where the character is also with the pen, I think the color detection becomes a lot harder. You can't just use color detection blocks in a basic way. You have to go more in depth. So I decided to use just a regular sprite for this one. Alright, so check this out. So I'm going to go over every block of code in this, besides like all the trash that isn't in here for no reason. So this doesn't matter. This is just the soundtrack. I uploaded that from YouTube. So this is probably the most important program of the program. So it's the program for drawing a line. And basically on every level, I call in multiple of these programs with different coordinates, as you can see, X, X, Y, Y, and then what color the line is. So we have like, over here we have blue, red, green, gray, So this says, I don't think I ever actually use this variable. I should probably throw that away. Actually, let's do that. No, we'll just see if I use it. So off the screen means this is asking whether to render the object or not. So if the object is in Scratch, if the object is off of it, should be off of the screen. It actually you can still see it. You can still see the border, and you don't want things to just move. When things go off of your screen, you don't want them to just still be there in the corner. That's really annoying to look at, and it'll get super crowded. So this is the variable that detects whether they should be on the screen or not. It sets it to 0. It says put this on the screen, and then it says if you're either if you're off the left side of the screen, off of the upper side of the screen, the right side of the screen. This is the left side of the screen, or the lower side of the screen. You're going to set that to 1, and then you can see all of the rest of this code is if it's 0. So if it's 1, nothing happens. In Scratch, I thought this would be harder for Scratch to run, but Scratch actually runs the pen very well, which is why there are a lot of pen platformers, because you can make a pretty in-depth platformer. Okay, so the switcheroo variable is used for a specific block in this game that switches all the colors. I'm going to ignore that for now. So this is color detection. So the way that I made this block using the My Blocks thing. You can see I have a bunch of these. So these so when you make one, it's going to automatically give you a defined thing, and when you can edit it, or when you're making it, you can add variables to input. So I've added 5 here. You can see one of them here is color. So anything in this script, if it says color, it just applies to this. It applies to that. Alright, so as you can see here, this is telling it to, depending on what number I write in for my color, which I have memorized, it'll output a certain color. Talk about switcheroo later, as I said. Okay, so the pen is still up. We've not drawn anything yet. We've set the pen color. Up there we set the pen size to 10. That was a while up. It sets it to 5 here because that's just a different block. I'll show you that later. Okay, so this is where it gets kind of confusing. So another thing, this is the same thing I mentioned before with off the screen. So Scratch, if the pen tries to draw something past the farthest boundary of any side, which is like 240, right? Then it will just draw it at 240. It won't let's see. This is hard to describe, but basically, if you have a diagonal line, And the second point on the line goes off the screen, but the first one doesn't, so it's still on the screen. The second point is going to stay exactly where it is until the first point goes off the screen, which is bad for scrolling platformer. It's just going to make the diagonal thing adjust, which won't actually matter in gameplay, but it'll look really weird. So I have a program here. Scroll X and scroll Y are the variables that define where you are. So you start out at 0, 0. Every level starts out with 0, 0. When you move, things will adjust to where you are. Like in all side scrollers, you don't actually move. Everything around you moves. Okay, so here's what this is saying. If the first point is too far to the left, then I used y equals mx plus b to find a place that it should go to instead of just your normal point. Otherwise, go to the normal place. So you still haven't drawn anything, but you've gone to the first point. Then you put your pen down. And then you kind of did the equivalent thing for this one. If the second point, I made it so that the second x point is always larger than the first one to not avoid any mix-ups. If the second point is too far to the right, that's the exact same thing. Otherwise, just draw a regular second point. So at this point, you've drawn the line. You've gone to point 1, put your pen down, and then drawn to point 2. Then you can see you put your pen up again. So that's the basic line drawing thing. That's all you need in a regular platformer. I just added a bunch of effects in mine. You can see the one I'm going to be showing you right now is all these dots. I think they make it look kind of cool. I used some actually trig to do this. You can add whatever effects you want. I'll just show you how I did this one. So I set my transparency to 60. That's how bright these dots are. The more this number is, the more transparent it will be. You can see if I set it to 10, they will not be transparent. Now they just look like the rest of the stuff, and it's going to be really confusing. So, the nice thing about this kind of platformer too is whenever you adjust the code, it's going to auto-adjust because this kind of code is frame-based. The pen platformers are all frame-based, so every frame this will adjust whatever code I have here. Okay, so we take the pen up again. We're moving on to a new place. Yeah, this is going to look really confusing if you didn't make it, but I was kind of just, so I have this variable that's called switch change that I use in a lot of situations. I can show you it right now. It's going to be it's going to be crazy. Okay, well, I guess it's not that much right now, but switch chain continuously goes up forever, which seems like it would not be useful except when you're dealing with trig because all trig functions go up and down no matter what the variable is. So I could have it like go up 90 then go down 90, but that's harder to, technically that'll make it slower because it's more code. So here we go. I take the sign of this variable. That will get me a number between, if I remember correctly, it'll get me a number between -1 and 1. So multiply that by 10. So you get between -10 and 10. And it's going to adjust. See how these dots, you see here, they're moving left and right. And up and down a little bit. So we have this, right? This is what makes it move left and right. And then you have what this does. Okay, so x2 minus x1, that's the difference in the two x points divided by 2. So that's half the difference between the two x points plus the first x point. So if you haven't figured this out already, what that's going to give you, you can see here, right? So first x point, this is the distance between them. This is half the distance between them. If we take this distance, add it to the first x point, we'll get right here. What that gives you all the time is the middle of the 2 points. We take the middle of the 2 points, and that's it. We just add it to, that's it. So yeah, we do that, and we just add it to the sign, and that will give us something that's gonna be directly in between the 2 points and going left and right. With the y, so y1 plus scroll y plus 10 is going to be about 10 above the line. It's going to be about 10 units above the line. And we do the exact same thing here. So it's plus or minus 10, right? So it's going to be between 0 and 20 above the line. You can see these, there's a dot right here, right? And this one eventually goes down all the way down to the line. That's 0. Okay, so that's this one. The next one is looking exactly the same on the x, right? And for the y, this time it's negative 10. So this one's going to be exactly the same, except it's going to be below the bar. You can see it should come down right about now. Here it is. This is the one that's below the bar. So that's this. That's those two. Then we're using some cosines. So the only reason you'd use a cosine function is almost exactly the same as a sine. Except it's always, how do I put this? It's always reverse of the sine. So when a sine is 1, the cosine is -1. Yeah. Is that right? I think that's right. So basically all I'm doing here is I'm making, well, some of them are going up, the other ones are going down. So you can see, like, there's a clear difference between these points in the directions they're moving. That's the only reason I use cosines. Otherwise, you can see this is exactly the same. Oh yeah, this is exactly the same. And it is, so it's exactly the same as this one, right? Except for it's a cosine, and this one is exactly the same as this one, except it's a cosine. That's it. That just produces essentially. Okay, so I actually messed up here. I didn't realize that this is actually equivalent to this, and this is equivalent to that. So these actually aren't needed, but it makes 2 dots per line. There are 4 dots here. The reason for that is this is actually 2 lines. I messed up. Initially, I never quite fixed the problem, but this is 2 lines. Okay, next up. So we've made the dots and the line. Next up, we are going to. Okay, I don't know why that's there. Oh, that's something that doesn't matter. That's something I trashed. That doesn't matter. Okay. So 6 and 7 I'm gonna mention later. And what I did is for 6 and 7, so this part of the code is this. See this little flashing effect? For things that are white or dark brown, they don't have the flashing effect. So I'm just saying if they're not white or dark brown, do the effect. Okay. So I have this variable called flicker. I think it's in this sprite, but I'm not going to show it to you. It does, what it does is it fluctuates between 50 and 100. So it starts at 50, adds 50 over time, and then subtracts 50 over time, and repeats that forever. So we're setting the pen transparency to flicker. This is the exact same thing. So it's the same thing. We're like adjusting the point if it's diagonal. The only difference here is we've offset the x and y by 5. Don't need to offset that by 5 because it would be exactly the same. So this is, you can see these, they're like diagonally offset by 5. And it's the exact same here. So that's pretty simple. It's a mirror image that's between 50 and 100 transparency. If you remember, 100 transparency is not there at all. So it eventually is not there at all. And 50 is like halfway, you know. And at the end, remember to put the pen up. Otherwise, it's a disaster and you'll have lines connecting everything. And it'll look really weird. Never mind. I guess that, okay, well, maybe I already did something to counteract that. Anyway, so, arrows. Yeah, that's, okay, this is a good time to talk about arrows. So there's a lot of arrows in this program. Yeah, there are quite a few arrows here. And basically, oh, I should really have that variable. The arrow, okay, so every arrow is 3 lines, and I would really rather not have to code all 3 lines. So I made a code for the arrows instead where you don't need a color input because all arrows are gray, which is the color 5 for me. I did put a direction input, so that's if it's going left, right, up, or down. The diagonal lines will have to adjust. So you can see here, 2 is going to be to the right. That's just what I set it as. So you can see this first line. It's going to be, this is perfect. This is the line. This is the one going to the right. So the first line is this one. It's x2 minus 15 to x2. So it's going from here to here, and y2 plus 15 to y2. So it's going x2 minus 15 plus 15 on the y is there, and then x2 to y2. So that's going to be right here. That's the second point of the line. The other one is almost exactly the same, except instead of plus 15 here, it's minus 15. So it's going to be, instead of up here, below. That's for the going forward. For going up, let's see. Okay, I think there's one like at the beginning, right? Yeah. So for going up, it's x2 minus 15 to x2. So that's going to be potentially from here to here, right? And then y2 minus 15 to y2. So this is y2 minus 15, and then it goes up to y2. So combine those, and we have here to here. The second one is x2 to x2 plus 15. That will be here to here. And y2 to y2 minus 15. So that would be here to here. So we combine those, and we get this line. That's the up one. So these don't need much explaining. This is going to the left. I did 1, 2, 3, 4 is clockwise, starting with up. So 1, 2, 3, 4. So 4 is left. Okay, this is shouldn't take much explaining. This is the exact opposite in terms of the x positions from going forward. So see, I'm kind of lazy. I didn't even take out the minus terms. I just made the numbers negative, so I'm subtracting a negative, which is the same as adding. And same for downwards arrow. So instead of going from up to down with the y, which would be like that, I'm going from up to. Okay, so this is going from down to up on the first one, and up to down on the second one. This one's going up to down on the first one and down to up on the second one. Okay, those are the arrows. I did that to save time. This is all trash. This is super simple. It looks complicated. This is insanely simple. Okay, this is the core. Without this, everything would be gone. I'll show you. So you can see there's a single frame, and then it's just done, right? And then if I click it, it will render. But if we want it to continuously render, we're going to just hit that forever, right? Now it looks fine. So here's render. Erase all. At the beginning of each render, you're going to erase. This is why this is frame based. So you're going to erase. What this does is it erases everything, and then it immediately draws everything in whatever new form it took. So draw behind is a blank. I started using that and then deleted it, so that doesn't do anything. So this is defining what happens in each level. So in level 1, actually I'll show you every single part of it. Okay, background. That's this part. You see these circles? That's the latest edition. Make it look cool. That's the background. This is, I could have saved time and just put background up here, but I decided not to. Okay, so background, did that. Line from negative 50 to 150, negative 75, negative 75. I'm going to give you a hint. This is negative 75. This y position is negative 75. So, negative 50, yep, that looks about right, right? If you've used Scratch before, you know that that's 0, so that's about negative 50, right? And that's 150, so that's this line. 1 means blue. There's 0 red in this. So you're just going to see 1s and 3s, and 3 is the green, which sends you to the next level. Okay, next one. This is 50 to 100, 0, 0, 1. So this is going to be 50. That's about 50 to 100. Okay, this is the part where I made 2. Okay, you know what? I'm just going to adjust this right now. I have to deal with it more. You can see this is going to look almost exactly the same. You'll notice a very small difference, but there used to be like a little dot here, but now there's not. Okay, so 50 to 150, 0, 0, 1. This is about 50. We already know this is 150 because that is 150. 0, this, okay, because you can see when I hit start, you actually start up there, so this is considered 0, which is why this is 0. So that's this line. The next line is 150, 150, negative 65, 0. We already established that this is 150, negative 65, 0. We already know that that's 0. So those are those 3 lines. Okay. I'll show you the arrows too. I'll find some way to die on level 1, which is hard unless you're like never played this game before. Okay. Or rather, never played a Scratch platformer before. Okay, this is the next line. I did them in order. Okay, it's getting harder to keep track of showing it to you. 400, 400, 0, 100. You have to trust me on this. I measured it out. This is 400. Because we've scrolled all the way from like here, right? It's about 400. It's 400. Just trust me. Okay, so 0, 100. This is 0. We've actually already jumped up, so we started out down there, but this is 0 and this is 100. So that's this line. This is a little, okay, when you're in the editor, these projects become kind of framed, which is kind of annoying. This next one, easier to measure, 500, 600, 0, 0. This is 400. This makes sense. It's about 100, and it's about 100 again. So 400, 500, 600, 0, 0. This is 0. We already established that. Okay, that's that one. I just added acceleration to this game, so this might be impossible, actually, but I can change that. But no, it's not. Okay, so. Okay. This is the last blue line. It's 900, 1000, 001. Again, you're gonna have to trust me on this. This is 900. I'm just telling you that. This is 900. This is about 100 away. This is 1000, and we're still at 0. That's that line. Next one is 1000, 1000, 075, 3. We've already established that this is 1000. This is 0. We've already established that. This is about 75, so that's 0, 75. 3 means green. I made red before green, but then ended up never using red in the first level, so that's why this is 3, and I never introduced 2. Okay, so now I'm going to die and show you the arrows. I'm not going to do this for all the levels, just the first one. Just to demonstrate render. Okay, arrows are a little different. You have to remember that the fifth variable is not the color, it's the direction. So there are 2's here, but that just means they're going arrows that are pointing forward. Okay, 0, 0, negative 25, negative 25. It's the same. For some of the programs that are in this that are for drawing, the coordinates are not like this, but in this case, it's the same as drawing lines. X1, X2, Y1, Y2. Okay, 0, 0. Yep, this is 0, 0, 0. And the arrow code, as I've said, so it's for this line, and then it, as you saw in the arrow code, that just draws these 2 lines for you. So that's 0 to 0, negative 25 to 25. This is about negative 25. That's about 50 more than it. 1. That means it's going up. Okay. Next one is it's this one. 80, 120, 100, 100, 2. So this is 0. You can see that that's about 80. That's about 80. 80, 120. Never make arrows super short because these things don't automatically adjust the length. I could make them do that, but that would take longer and yeah, make the code longer and stuff like that. Wanted to keep it a little simpler. So 80, 120, 100, 100. What was this again? This was 0, right? Okay, yeah, this is 0. This is negative 75. 0. That 75 takes you about up to here, and then that's 100 right there. That's this one. 2 means it's going forward. Okay. Oh, it's so framed. Jesus. I swear, if you go to this project when you're not in the editor, like just viewing it from an outsider's perspective, it's not framed like this, unless you're on like a Chromebook or whatever. Okay, final arrow on this one. 530, 580, 100, 102. I had to experiment with the numbers because you can't just measure 500 on the scratch screen. Okay, but trust me, this is 530, this is 580. If you remember, 500, 600, so that's about 20 and that's about 30 right there. 100, 100, we've established that this was 100, I believe, so that's still 100, and 2 means it's going forward. Okay, I'm not going to explain all of this, but as you can, so this is all of the code for all of the levels. I have like 9 levels right now, I think. And the cool thing about a pen platformer is you oh, that is not good. I should change. Okay, if you don't put I don't know, shoot, I'll have to go to level 6, but if you don't put a color variable next to a line, it's going to randomly change colors sometimes because of things happening. Like if the line before it goes off screen, it won't draw the line, but it'll still set the color, and then this one won't be set, so that's definitely a problem. Anyway, you see other codes here. These are, I'll show you these. They're lower down. I organized all. That's all trash. Okay, this is the forever code. So and another backbone, although it doesn't do that much. So sets flicker to 50. As I said, flicker starts at 50 and then goes to 100, then back to 50, then up to 100 again. So, okay, that's not necessary, but it happened. That's also not necessary. That's also not necessary. That is necessary. Okay, so that's necessary. Yeah, so this at the beginning sets your x and y to 0, which is right up here. And it sets your level to 1. This is level 1. You hide this sprite because you don't need it at all. And you render forever. So it is continuously rendering every frame. Super simple. Okay, background. This was added very recently. If you don't know what these are, this is a list. I could have made 10 variables, but I don't like having 10 variables with all very similar names. I made a list. It's a little harder to control, but it's nicer to look at. So I have something to control all of these list variables, which should be down here somewhere. But you can look at them here. So this is for the background. Okay, this is a actually very important note about pen platformers. Never use a repeat command. It's really annoying, but Scratch takes too long to execute a repeat command to be able to run a pen platformer every frame. So you have to just use the raw code. You can't use repeat commands, which is why this took forever to make, because everything is slightly different. Okay. So what this does is it renders every single circle in the background. It sets their sizes and their transparencies. If you look closely here, the ones that are smaller are less transparent. So this one is about to disappear completely. Then it'll come back into focus, right? And then it'll become pretty opaque. I mean, not very, but comparatively. Okay. So these variables conveniently control the opacity and also the size. Okay, so set pen color to dark gray. These are very transparent, but if they weren't, they would be dark gray. Pen size to 100, that's not necessary. Transparency to 50, that's not necessary either. Okay, here we go. So item 1 is this first one. Unlike a lot of codes, Scratch doesn't have the item 0 thing, which means the first item is actually item 0, which can be nice. So item 1, this is going to be, okay, it's hard to see, but it's the upper right one. It's pretty cut off here, but, so it's number 1. This one ranges between, what does it range between, like, let's see, like, I think 70 and 150, I want to say? I don't know. I can't really tell. But it sets the pen size somewhere between 70 and 150. It's continuously changing by 1. Although you can see these other ones are not. Because I'll explain why. Transparency is just the same variable. I divided them all by a little bit because otherwise it'd be kind of weird because these would be like almost as opaque as the other stuff, and that'd be really weird. It's a background. But I don't like having to create a bunch of variables, so I try to reuse variables as much as I can. This is called sizes. I only had one list. Sizes. Okay. And then the location of the first one is at negative 220, 160. It's way up here. Right, first one. Then this is basically a stamp, pen down, pen up. Just puts the pen there, sets it down, and then picks it up again. Okay, I'm not going to go through all of these. Basically what's happening here is now we have item 2. This one is different. It fluctuates between different numbers. It's going to go not as big and not as small. And it's the exact same thing. It's positioned right here. You can see it. That one. That one. And then this doesn't just keep going up because there's only 10 items in here. There's a lot more than 10 circles. There's like 30 or something. So you can see this is pretty regular going up to 6. And then what happens is we start over with the next row. Right here. See, now it goes from 160 to 80. So y being 80 is going to set this one. Okay, so I've set this back to item 2. What that does, that's going to correlate this circle with this circle, and it's going to make the circles correlate in diagonal lines, which is creating this kind of diagonal fading effect. You can see it really well there. So that's why it switches to 2. Next time it's going to go up to 7. The reason for that is this one is creating a new diagonal. See, it's not so far. There's nothing there. So this is item 7. And we're going to reset to 3 because this one is aligned with all of these ones, right? All right. So that's once that's all done. That code's all. So again, I'm actually very impressed with Scratch being able to handle all of this, every single frame. Oh, here's the sizes code. This is cool. But I'm very impressed with being able to handle so much code. For some or basic engine like this, it should be pretty hard. Okay, so this is in case anybody messes with the sizes, including me. I accidentally mess with it, right? Okay, so delete all of sizes at the beginning. I'm not sure if you'll be able to. Yeah, it's too fast for you to see, but at the very beginning, sizes has nothing in it. And then it's going to add all of these in succession. So the first one will start at 150, second one will be 140, and so on. And then, okay, this is the size code. I used some quick math to do this. Calculator. So repeat 90. This is the fluctuation code. Super simple for the first one. So lists don't have the same code blocks as variables, which I find kind of annoying. Instead of changing a variable, you have to replace it with a new number. So it's kind of like old scripts where you had to do like x equals x plus 5 instead of x, or x equals x plus 1 instead of x double plus, right? So replace item 1 with item 1 minus 1, and you do that 9 times. So it's going to go from 150 to 60 over a while. To code all the other ones, I want them to all reach like their opposite place after 90 frames, if that makes sense. So the max for this one, I think, is like 8. I want to say 70, maybe. So I want this one to reach 70 at the same time that this reaches 60. And so if I had this changing by 1, this would go all the way down to, what am I saying? This would go, what am I saying? Okay, yeah, so this one starts at 140. If this went down 90 from 140, it would go down all the way to 50. And I want it to go to 70. So I need it to change by not quite 1. The way I did this, I know it needs to change by 70. 140 minus 70 is 70. So I did 70 over 90. And quick calculator, that is 0.77, about. So you can see there, 0.77. I don't need to do exact code because we are reversing it by the exact same amount after like 180 frames. So it won't like be exact. It won't go down to exactly 70, but it'll go back up to exactly 140. So it works out pretty well. It's exactly the same. As you can see, when we get down to 6, we are going to start adding values. That's because the 6th diagonal is where you start when these 5. Okay, it's really hard to see because these ones basically stay almost the same all the time, but this is hard to describe. So these circles in this half get bigger when these ones are getting smaller. So when these ones are getting smaller, these ones are getting bigger. So that's why this one has to go up, and these have to all go up. Number 10 is this one in the corner. It'll become visible. Yeah, it's this one. So this one is going to go at the same rate as item 1, except in the opposite direction. Alright, I don't need to explain that. This is just doing the exact inverse for 90, so it continuously waxes and wanes. Useless code. Oops, that was... Yeah, wait, what did I just hide? Did I hide the time? Yes, I did. Okay. That's also useless code. Draw floor. I believe that's also useless code. It's a lot of useless code in here. It's all useless code. Okay, draw square. I'm not going to show you this right now, but draw square. I had a level that was themed off of square shapes, and I didn't want to have to do 4 lines for every square, so I made a program. You could input the left X point. So let's say this was you could do rectangles too. If this was a rectangle, this would be the farmost X and the farmost Y. So left down corner of the square basically would be right here. You can put the width, the height, and the color of the square too. Okay, so the first line is going from the left X to the left X. So it's going from here to here so far. From the lower Y to the lower Y plus height. So the height here would be like 60 or something. So it would go from here to here. That's the first line. Do this one. Okay, the next one goes from left x to left x plus width. So that's going from here to here. And then from lower y plus height to lower y plus height, which is here. So it's going from here to there. Third one is left x plus width to left x plus width. So it's going so far from staying here. Then from lower y, which is this, to lower y plus height. So it's going like that. The final one is going from left x to left x plus width, and from lower y to lower y. So it's just going from here to here. And that will create us a rectangle. That's the program for a rectangle. Or a square, as I called it. Incorrectly called it. Oh boy. Okay, I might have to show you this one, because this one's actually pretty cool. So, here, scratch tip. If you go to a sprite or a backdrop that has very little code, it'll become a lot less framed when you run a program. So when you're playtesting, see, look, that's like barely framed, right? When you're playtesting, do that. Okay, this is, I wanted to show you this because this one's actually pretty cool. I developed this solo, didn't get any, I got some inspiration actually from, okay, that's a glitch. I technically hit the green there. I don't know if you saw it. Technically hit the green there, but, after I hit the red. So it's a bit of a glitch. Okay, I just added, normally that'd be a lot better at this. I just added acceleration to the motion, which makes the moves very, oh god, this is going to be hard. Yeah, this is going to be a very hard move. This might actually be impossible with how it is right now. No, it's possible. Hold on, let me just, there we go. Okay. Oh my god, that's hard. Jesus. Lord, this is hard. So, yeah, this is probably the hardest level in the game. There's another one. The one after this is also pretty hard, actually. Come on, yeah, okay. So, it becomes even harder with the acceleration thing. Okay, this one after. Oh, damn it. You know what? Screw this. I'm just gonna change the level by 1 until I get to the right one. Okay, here we go. So, these are the switches. I mentioned them earlier. I call it like the variable was like switcheroo. Here, I'll dive real quick. So as you can see, when you hit this white, watch, all the colors switch, and this brown one up there switches them back. Okay, but this is where was I? So this creates that beautiful rotating thing in perspective, right? I'm not going to explain this because there is absolutely no reason you need it in your platformer. There's zero reason. I used some trick. I was messing around, and I managed to create something that's actually pretty cool. Okay. Draw rotating bar. This comes into effect unlike the last level that I've created. I'll explain this one. This could be useful if you're making a platformer. Okay. So, the inputs are X, Y, color, and height. I should rearrange these, but I'm not sure I can. So, very simple. This is X refers to the bottom. Oh no, the top actually. It refers to the top. Kind of weird. So, here's the line. It's going from X plus 30. Oh, X plus 30 times sine of switch. If you remember, switch change is that thing that just keeps going up. So the sine of switch changes between -1 and 1. 30 times that is -30 and 30. So it's X plus 30. So, X plus a random amount. So at this point, it would be going back and forth, right? These are exactly the same. It would be going back and forth. The Y I used cosine for some reason. I don't know why. I think otherwise it would go like counterclockwise or something. I don't really remember, but that doesn't really matter. So the only difference here is very similar, as you can see. Except I subtracted height here and didn't subtract it there. What that does is so the Y is also going up and down to make it really go in a circle. But this one is subtracted by the height, and this one is not. So it's going to be from there to there. It's going to be like, it's it's like this bar, right? And it rotates. So it's a rotating bar. The rotating block, it's rotating line, basically. It's exactly the inverse. So instead of the y being like that, the x is like that, and it takes a width variable. Very simple. Oh, that's it. Oh, never mind, that's not. Okay, now for all the color detection. You want to make sure, put all your color detection in the actual sprite because your pen can't detect colors. I mean, technically it can, but it will mess up everything. Okay, by the way, that's switch change. Very simple. Continuously goes up forever. That's flicker, as you see. So demonstrated those with the flashing and the signs and stuff. Okay, so I don't know why that's there. Okay, I'm gonna explain all of these. So never mind. Actually, I might not need to. So this is just the sprite is always at 0, 0. You can see like it's not actually. If I keep my cursor on it and move, it's always at the same point on the screen. It's always at 0, 0. Okay. So if I were to, oh whoops, I can actually go to the code here. But what this is saying is if so there's this tiny little thing here that's this color. What's that thing? Is if that's touching this blue, which can act as a wall. Repeat until it's not touching that blue. Change scroll X by 5. And kind of weird, but 5 is actually going to make you go backwards 5. So if you ran into a wall, I'll demonstrate it right now. If you run into a wall on the right, it's going to just send you back. Well, you can see here, it's just, yeah, so it's just not doing anything because the other part of the code, I'm holding D right now. The other part of the code is telling it to go change scroll X by -5. And so it's canceling out and not doing anything. Okay, exact same for the left side. So if it's touching on the left, it'll push it to the right. Put a lighter gray on the left, it's unnoticeable. Start click, switch over to 0. Yeah, definitely do that because otherwise when you start, everything might be red. So, okay, so I didn't want you to have to hit restart and just keep falling, right? If you fall off, I wanted there to be a point where you just respawn immediately. And I made that 400. So if you're 400 below the spawn point, it just resets you. And there is like the last level goes down to like 350, so it really pushes the budget. But so this is the death code. If you're at that point, or if you're touching red, which is the death block, then it sets you back to 0, 0, which is the spawn point on every level. Stops you from falling insanely fast if you were down here, because you do accelerate. That's how gravity works. Sets your bounce speed to 0. If you died after bouncing on a trampoline, you're not going to keep bouncing when you respawn, and set your switch to 0. So on the switch levels, when you respawn, you will just continue dying because the ground will be red and you will not be able to get out of it. Okay, that's the death code. Very simple. This is the next level code. So if you touch the green, exactly the same except you change the level by 1, which sets the code so that all of the lines are now for the next level. At this point, so far I have 9 levels. If at this point level equals 10, it will just, if your time is a record, it will set it as a record, and then it'll set you back to level 1, just for now, for playtesting purposes. These are the switch detection. So if you were touching, these are actually unnecessary. I had a bug, and I was trying to get rid of it, and that's one of the ways I tried, but it doesn't really matter, so. This is the first switch. So these only activate if you're currently not switched, and it'll switch you. It'll set your switch variable to 1. The second switch is if your switch variable is 1, it'll set it back to 0. White and dark brown, those are the switch colors. Okay. This next one is for moving. As you can see, there's acceleration code here that I just added because of a request from a friend. Okay. So, the acceleration code. Ooh, there might be. This new acceleration stuff may actually be a problem. Just with having to wall jump on one of the levels, now that I'm thinking about it. But let's pretend it's not there. Okay, I'm going to tell you how it would be if the acceleration wasn't there, because I'm about to change it back real fast, because I think it's going to mess me up a little bit. Okay, so if you are not running into a wall on either side, then you're allowed to move, right? That's how moving works in the real world. So every time you receive a move, you're going to set your acceleration to 0. You know, I'm going to explain it with acceleration, whatever. Set your acceleration to 0. This is every frame, sorry. Every frame. And then, if you're pressing key A, set it to... Okay, that's unnecessary. Repeat until you're not. Speed yourself up, and then change your scroll X by the acceleration. And then in between A and D, it sets it back to 0. Although that's unnecessary, as you can see. It does the exact same thing here. What? I thought I organized this. Is it a glitch? Oh boy. Okay, that worked. This is the... What is this? This is the fall code, I think, right? Yeah, this is the fall code. So fall speed is your gravity, basically. Forever, you're going to set it to 0. And then, if you're not touching the ground, repeat until you are touching the ground. Yeah, it's super simple. So just change your scroll Y by... it's going to be a positive number because fall speed is negative, multiplied by -1, kind of unnecessary, but makes it positive. If you remember, scroll X and scroll Y are counterintuitive. So if you increase scroll X, you will go to the left, and you increase scroll Y, you'll go down, which is what we want. We want to go down. So repeat until you're touching the ground, go down. Then you're going to set it back to 0. Okay, this light gray is the top of your head. Look at the top of his head, right? That's that. If that's touching the blue, you're going to change it by 4. So as you can see here, it just bounces you down a bit. And it also, because of the color detection there, maybe it's moving you to the left. Oh, there's a glitch where you get stuck on the top. Don't worry about that. Okay, so that just bounces you down so you don't get stuck on the roof. This is the trampoline code. So this is the trampoline code, this orange. If you're touching trampoline and the ground at the same time, that's an important note. In this game, you have to touch both of them. That's not always necessary, but it fixed me a bug. Okay, your bounce speed starts at 15. You change your scroll Y by -1 times bounce speed. Again, counterintuitive, but this propels you upwards. Okay, now you do that. Okay, this is also a bug fixer. When you hit the orange, you automatically go up by 15 before initiating the rest of the code. Then repeat until your bounce speed is so small that it's basically dead, as you call in the coding world, or until the top of your head touches the ceiling. Keep going upwards and keep changing your bounce speed. Keep adjusting it downwards a bit so that you don't go up forever. That's the bounce code. Okay, this is the jumping code. I think this might be the last one. Yeah, it's the last one. And again, these are not all necessary in the basic one. I'll just go through all the real necessary ones at the end here. This is jumping code. If you hit W, which is the jump key, you can make gravity faster. I made gravity pretty slow in this game. And then now that I've made 9, I would make it faster, but now that I've made 9 levels, I decided not to. Because it would mess everything up. Okay, you hit W. If you're touching the ground, because you can't jump, you can't double jump, you can't jump while you're in the air, right? And you can't jump when you're touching a ceiling. That would be kind of dumb. The reason why I did that is because technically you're touching the ground, because blue is the ground. So technically you're touching the ground, right? What the heck? Okay. So as long as you're not touching the ceiling, set your jump speed to 10. Not quite as powerful as a trampoline. Okay, and this is kind of the exact same thing as a trampoline, just not as powerful because it starts at 10 and not 15. Also, there's no initial jump thing because there was no bug with jumping while there was with the trampoline for some reason. Okay, that pretty much wraps it up for that's what made this platformer. But there's, in terms of basic code that you actually need, all you need is that first part of the... Okay, so don't get overwhelmed by that initial... where is it? Not this. That you will need. But okay, my line code is extremely long. And the reason for that is mainly because of the effects. It would be extremely short if the effects weren't there. Let me just show you how short that would be, actually. This looks long, but it's just setting the color. That is still necessary. But here we go. So, take a look at this. What? Bob. That just deleted all the effects in the game. But it's still fine, right? It still looks fine. Looks a little cleaner, actually. Add it back, and we get all the effects back. So, you can delete all of this. I cut it off here because you need that pen up command, I think you do. No, doesn't matter for some reason. Oh, that's right, because I put the pen up at the beginning of the code, so that would be fine too. Yeah, so you only need the first part of that draw code. Don't need the arrows unless you want to have the directions like that. Your levels don't have to be this long. That can be simple. This is just, yeah. So that's, but you do need that. You do, oh, what the heck? Scratch is framed. It's very framed. Okay. Oh my god. You don't need trash, obviously. You do need this one. This is the one that just renders every frame. You don't need your background. I made that very recently, in fact. I did not have a background for a while. Don't need that. Don't need any of that. Okay, so that's it. You need the line code, the render code, and the forever render code. You need, depending on your platform, you'll need different types of color detection, like running into a wall, hitting the ceiling. You'll probably need a jump code. You'll need a falling code, but that's pretty much it. That's it for our pen platformer. I'll just delete acceleration real fast because it messed me up. And then I'll do a quick run through. Just show you all the game. Oh boy, this is that real fast. This is actually so much more complicated with acceleration, I just realized. If you don't have acceleration, it's extremely not complicated. Just set that real fast. Should fix it. Sure. It's a lot easier to move without the accelerator. Yeah, that's it. Okay. Let me show you. If you want the best frames, go to the project page. Pen platformers, always advised, you can see I did it here. Do not run full screen on a pen platform because it looks pixelated, especially with diagonal lines. So I would run it, unless you're a speedrunner, I would run it normally. Oh, this is still, no, that's not very framed. Okay, here we go. The only reason I'm like a legend at this platformer, this would be harder if you had not played this before. That's why I have the arrows. Here we go. This is the level started to get hard at around level 5. That's what I did. Obviously, that's not an instruction. Just like at one point, make it. Okay, this is. Wait, I did that wrong. Nobody can do this level first try every time. Just like it's tough to master this level, as you can see from how I'm failing here. Okay. There we go. Level 6 here, I believe. Oh, I haven't added levels on level. I haven't added arrows on level 9. So if you do, go to this. Ooh, that's also not a first try jump right there. I happened to first try it, but it's definitely not a first try jump. If you end up going to this game just to play it, which I advise, it's a cool game. Level 9 does not have arrows. You have to navigate your way around for now until I add them, which will probably be this afternoon. So, okay, here we go. This is level 7, I think. Yeah, this is the square theme level that I mentioned. The square code for. I think it makes it's kind of a cool effect, you know. Makes a lot of these dots because remember these dots are. See these dots? That's for every single line. Each of these squares is technically rendering 4 lines, so there's a lot of dots. Let's just say there's a lot. It's the square level. I mean, you can go way deeper into level design than I did here. This is the switch level, but I did not go very deep. I'm not a level design kind of guy. I'm more of a code kind of guy. I'm not a designer. Switch level is pretty interesting. It's also very short. Here's the final level that does not have arrows, or it has like a couple, I think. Yeah, these are the only 2 arrows it has. This is where I use the rotating bar. See, it's a demonstration. Rotating. Okay. There's also a soundtrack. I'm not playing it in the recorded stream because it is royalty free, but I'm not going to advertise somebody else. I'm not feeling like that. Jesus. This jump is not normally this hard. It's like, it's the barrier of, oh my god. It's the barrier of how high you can go. You also have to, oh. Come on. Yeah, there we go. Okay. This includes a very, very big drop. As I said, it goes down all the way to 350. And once you hit 400, you just die, which is why I could not make this level that long. But there we go. And as you can see, for playtesting purposes, it restarts at the beginning. The reason why it was red for a second there is that there was a switch in the last level at the very end, so it was switched. But then when you die, the switch resets to 0. I just added the record time thing, so I guess I just had a world record. But yeah, that's the game. Thanks for watching. See you later, maybe with another tutorial. We'll see what happens. Okay, just turn that off. See you later.